Think that plumbing is just about connecting a bunch of random pipes? Think again. A lot of people don't realize it, but a properly installed plumbing system often comes down to the math. Don't believe me? Then I have a challenge for you. And some little known insight into the problem-solving knowledge a plumbing apprentice needs if they want to pass their plumbing license exam. Over recent years, several students and apprentices have reached out to me with an eerily similar and specific problem-solving question. That is, how do you determine the distance between equally spaced dual vents that are serving 6 equally spaced lavatories, some people call bathroom sinks, all installed along a common wall? Now, it's no coincidence that I keep getting asked the same question from different apprentices, because there's apparently a similar challenge question that's been reported to pop up as part of our Canadian Plumbing Certificate of Qualification exam, or what we sometimes call CFQ for short. For those who don't know, writing the intense 4-hour CFQ exam and passing it with a minimum grade of 70% is the final step necessary for a Canadian plumbing apprentice to earn their coveted plumbing license after so many years of hard work. As a matter of fact, I even remember getting a version of the same vent distancing question when I wrote for my licensing exam way back in the day, when the exams were chiseled onto stone tablets and we answered the questions using smoke signals. Maybe not that long ago. So it appears that a version of this exam question is still kicking around in some capacity, even after all these years. It makes me still feel somewhat relevant. But this exam question probably still exists for a good reason. Because a good qualified plumber needs to know how to ensure exact, precise symmetry and spacing between pipes, fixtures, and objects, often down to the millimeter or fractional inch, especially at the rough-in stage. And as silly as such an exam question might sound to some of you, and I assure you that the plumbing exam has no shortage of dumbfounding, irrelevant questions, this particular question is really useful for testing a plumber's ability to apply their math, logic, and problem-solving skills in a real-world setting. From my understanding, the alleged exam question typically provides you with the following information. The number of symmetrically spaced identical lavatories, I've always heard it to be 6, but don't get stuck on the number because the calculation method doesn't change regardless of the number of fixtures involved in the question. The end-to-end length of the common wall onto which the lavatories are installed, the width of the identical lavatories, and whether the spacing between each of the 2 outer lavatories and each respective wall end are either equal to the spacing that's between any 2 lavatories or half the spacing that's between any 2 lavatories. Here's my interpretation of how such a question might actually be presented on the exam, using some made-up dimensions and based on how I vaguely recall the question when I wrote for my license way back in the day. There are 6 equally spaced lavatories being served by equally spaced dual vents. The identical lavatories are installed across a wall that measures 17 feet 8 inches end to end. The space between the lavatories is the same as the space between the outer edges of the 2 outer lavatories and each end of the wall. If each lavatory measures 22 3/8 of an inch wide, then what is the center-to-center measurement between adjacent dual vents? Admittedly, that's a lot to unpack, and that's a big part of the problem. Apprentices read a question like this, and their brain starts to freak out in panic trying to make sense of this verbal diarrhea that's presented to them. So, for whenever you encounter a complex or confusing problem-solving scenario, whether it be in the workplace or during an exam, I strongly suggest the following 3 tips. 1. Always ask yourself when you're tackling a question like this, and this applies to every exam question you may encounter, what exactly does the question want you to answer? Specifically, what is it asking you to solve? In this case, the question's asking for the distance between adjacent dual vents. 2. As with any problem-solving scenario, I always recommend that you start with what's easy and list the facts or dimensions that are already known or already given, and then build up on top of those facts. This will help you sort out and organize the information more efficiently. And 3, draw out a quick and simple sketch of the scenario whenever you can. I can't stress how powerful this little step is. A rough diagram provides clarity by helping your brain visualize and plot what the scenario will look like in real life. Because trying to decipher a whole scramble of words and numbers in a paragraph can be understandably confusing, which I have no doubt is the exam creator's intent.
Those sneaky scoundrels.
As a side note, for these types of questions, the unit of measure doesn't really matter. It could be expressed in imperial or metric because the math's generally the same. I decided to use imperial measurements with fractions for American friends and to make it slightly more tricky due to the mismatched feet, inches, and fractional inches. And by the way, here in Canada, we often still use imperial units in our own lives, including the plumbing field, despite that the official Canadian unit of measure is supposed to be the metric system. So, if you can learn to work with these imperial measurements, then any metric variation of the question you may encounter is going to be a no-brainer for you. So let's start out by drawing our simple little picture. No, not that kind of picture. More specifically, what such a plumbing system described in the question might look like. First, we'll need a wall onto which to install the lavatories, or sinks if you prefer. We also know that we've got 6 lavatories. Easy enough. And a bit of rudimentary plumbing knowledge tells us that a dual vent will serve 2 fixtures, hence the term dual. Therefore, because there are 6 lavatories, then that means that there are 3 equally spaced vertical dual waste pipes being served by respective dual and continuous vents. Note that the actual number of dual vents doesn't matter in this case because we're looking for the center-to-center measurements between any 2 adjacent vents because they're all equally spaced anyway. But it still helps our brain to decipher things if we draw out the whole scenario. Now that we got our nifty little drawing, let's lay out the rest of the known information that's provided in the question. Each of the 6 identical lavatories measure 22 3/8 inches wide. Our total available wall space is 17 feet, 8 inches. Now, before we get into the number crunching math of it all, I want to reiterate the importance of simplifying as much as you can for yourself. Specifically, because we're dealing with imperial measurements and fractions, it'd be a little bit tricky to add them up because we're trying to combine feet with inches and fractional inches. None of them speak the same language, so to speak. Your goal should always be to make the numbers speak the same language by converting them to like units of measure, which will make it so much easier for you to work with them and minimizing the likelihood of making an error. In this case, the most practical and simple for me would be to convert all the numbers to inches and decimal inches. Again, if things were metric numbers, things would be a little more straightforward since metric values convert to decimal quite naturally. Therefore, 22 3/8 of an inch is equal to 22.375 inches. Quick math lesson. We find our decimal value by simply dividing the numerator, 3, by the denominator, 8. Try to imagine any fraction as nothing more than a division problem because in reality that's really what it is. Our 17 feet 8 inches becomes 17 feet times 12 inches per foot, which is 204 inches, plus the existing 8 inches from the original value, for a grand total of 212 inches that makes up the entire available end-to-end wall space. Now that all the numbers are simplified and speaking the same language, let's take a look at what this looks like on our drawing. As a reminder, we're trying to find the distance between any 2 adjacent dual vents. Although we know the width of the lavatories, what isn't known is the space that's not occupying the lavatories, or what we'll call unoccupied wall space. The next step is to use the information in the question to help us figure that out. And we're going to do that by deducting the total wall space taken up by the lavatories, which we'll call occupied or even lavatory space, from the total length of the wall. So, if each lavatory measures 22.375 inches in width, and we have 6 lavatories, then the total wall space occupied by all 6 lavatories is 134.25 inches. The next step is to deduct the occupied amount from the total end-to-end wall length, which will give us a total unoccupied wall space, or whatever space the lavs aren't taking up. Therefore, if our total available wall space is 212 inches and the lavatories are taking up 134.25 inches of that wall space, then we're left with 77.75 inches of total unoccupied space. But that total unoccupied wall space on its own isn't really going to help us figure out our vent-to-vent distance. So we're going to take that total distance of 77.75 inches divided by the total number of whole unoccupied spaces that exist across the entire wall, which will allow us to determine the measurement for each individual unoccupied space. Because our question states that all unoccupied spaces are equal, then we simply count all unoccupied spaces as one whole space, including the 2 outer spaces. Now, I emphasize the word whole because you might receive a variation of the question that declares that the 2 outer spaces are only half the width of the measurement between any 2 lavatories. In such a scenario, you'd have to add the outer two half spaces together to equal one whole space. Doing that just makes those halves easier to work with when you add them up. You then need to add the combined outer total unoccupied space to the 5 whole unoccupied spaces between each lavatories, which will give you 6 whole spaces. And if you stick around to the end of the video, I'm going to show you an awesome trick that'll get you the answer ridiculously easy if you happen to get the half space version of that question on your exam. But let's get back to our current example where all unoccupied spaces are already equal. We simply count each unoccupied space, giving us a total of 7 whole unoccupied spaces. Therefore, 77.75 inches of total unoccupied space divided by 7 whole spaces would equal 11.107 inches, accounting for each unoccupied space. With all the measurements now figured out and the hard work out of the way, you could probably start to see how we can solve for the vent-to-vent distance. Let's take a closer look at what's between any two adjacent vents. We've got a half unoccupied space, plus a lavatory, plus a whole unoccupied space, plus another lavatory, plus another half unoccupied space. And remember, 2 half spaces equals 1 whole space. So you don't need to worry about trying to figure out what the length of a half space is, since you're going to end up with whole space values between vents anyway. If we simplify this, it's going to look like 2 whole spaces, those are the 2 half spaces plus the 1 whole space, at 11.107 inches each, giving you 22.214 inches, and 2 lavatories at 22.375 inches each, for a combined length of 44.75 inches. And when added all up, it equals a grand total of 66.964 inches between any 2 adjacent vents, center to center. Now, if your question's presented to you in metric, you're pretty much done. Simply look for the closest multiple choice answer that matches, accounting for any potential minor differences in rounding. But if your question's in imperial units, your multiple choice answers might likely be presented in feet, inches, and fractional inches. So let's convert our answer to that format. 66.964 inches divided by 12 inches per foot equals 5.5803 feet. Now, a lot of people get confused with the decimal portion of the value at this point, often incorrectly presuming that the decimal value refers to inches, such as 5 and some odd inches in this case. The decimal value you see here does not refer to inches. Always remain mindful of the units of measure you're working with. The 0.5803 in this case refers to how many fractions of a foot you have remaining, not inches. Looked at another way, it's saying that we've got 5 whole feet plus 58% of a whole foot. To convert those decimal feet to inches, we have to multiply the decimal feet of 0.5803 by 12, because there are 12 inches in a foot, which equals 6.9636 inches. And finally, let's convert the fractional inches to 1/16ths of an inch, because 1/16ths will provide us with more than enough accuracy for our purposes. We do so by multiplying 0.9636 of an inch by 16, which will give us 15/16ths of an inch rounded to the closest whole value. Therefore, the answer you should be looking for is a distance of 5 feet, 6 and 15/16ths of an inch between adjacent dual vents, or the closest answer to it, which may slightly differ due to rounding discrepancies made during your earlier calculations. Now, here's the little secret that I wanted to share. In the event you come across the version of the question that has the 2 outer spaces measuring only half the distance between any 2 lavatories, you can certainly solve it by torturing yourself using all the math steps we just discussed. Or you can solve for the answer by simply dividing the total wall space by the total number of dual vents in the system, which would be 3 in the event of 6 fixtures. No other math necessary. The reason this works is because if the 2 outer spaces are half spaces, then that will allow for an equal distribution of spacing next to each side of every vent pipe. If that doesn't make sense to you, here's an easy way to remember whether you can use the dividing trick. If your scenario consists of an even number of whole unoccupied spaces, then simply divide the total wall space by the number of vents and you'll end up with your answer. If you have an odd number of whole unoccupied spaces, as was the case in our hypothetical question, then your best bet is to solve it by going through all the previous calculation steps. If you managed to endure this far into the video, I thank you and commend you for your fortitude and patience. But you may be scratching your head wondering, why in the world would the powers that be impose such a strange, seemingly pointless question on the plumbing license exam? I assure you that it's not to torture you. Well, yeah, maybe a little. But other than for the purpose of adding misery to your life, such a problem-solving scenario is indicative of the many challenges good plumbers often face regularly on the job site. And yes, math is indeed a big factor in resolving those challenges accurately and efficiently. If you're a plumber or apprentice who's watching this, let me know in the comments below how important you think math is in the plumbing field, or share any ways where you may already be incorporating math into your perfect plumbing. While you're at it, please do let me know if there's any other plumbing mystery or challenge that's been keeping you up at night. We'll see if we can shed some light on it together. If you did get some value from this video, please be sure to like and subscribe so that I know whether you'd like to see more content like this. In the meantime, if you'd like to take a break from all this math and learn about what's involved with roughing in a 4-piece bathroom, be sure to check out this video right here. Till next time, thanks for watching.